Welcome to lesson on 7.2, finding complex solutions of polynomial and equations. So there are a few things that we should know before we continue to learn about polynomial equations, guys. Okay. We need to find the correspondence between the number of complex zeros, meaning when you set the polynomial equal to zeros, and in a factor form, its exponent values. Okay. So let's go through this, guys. We have we learn many ways to sort of factor polynomials. You know, when you divide things, guys, or graphing, right? We could find the roots, the x-intercepts, right, of both by algebraic or graphical approach. And we often do that by setting the polynomial equal to 0, right? And then what we discovered was that some polynomials can have multiple factors. And the multiplicity, this is a new word for us, multiplicity of a zero of the polynomial, or the root of p of x equal to 0, is equal to the number of times the related factor occurs in factorization. And this is usually indicated by the exponent of a factor. Okay? All right, let's go ahead and do an exercise. Example 1. Find all zeros of p of x when p of x is equal to x cubed plus 7x squared. We need to include any multiplicities greater than 1. So once you factor them, when the exponent is bigger than 1, we need to make a special mention of that. So the p of x is x cubed plus 7x squared. We need to set it equal to 0. That's how you find the 0, right? Setting the polynomial equal to 0. The first thing we always do is look for the GCF. In this case, turns out to be, that's right, guys, x squared. And what's remaining, x squared times x gives you x to the third. X squared times 7 gives you 7x squared, right? Set that equal to 0. And then this is a step that is optional for you guys, is x squared is equal to 0 because of the product rule, right? When items are being multiplied and the result is equal to 0, means that some or all of the factors must be 0. So that means that x squared could be 0, or x plus 7 could be 0. So that means that x could be 0 here, x could be negative 7. For those of you who feel comfortable doing this mentally, I'll let you do it without penalty. So the x in this case is negative 7 and 0. So sometimes we write down dr underneath to say it's a double root. But because the question has indicated that we should make a special mention of the multiplicity, so we say that the 0 is a double root, or we could say has multiplicity of 2. It means the exponent is 2, because there are 2 of them, right? X times x. All right, guys, so we do have example 2, but we will wait until the class time. We'll do that in class, okay, guys? So skip that. If you don't look it over, great. Actually, I recommend that, but I like to do that together in the classroom. So there's a fundamental theorem of algebra that we need to understand. It says that every polynomial function of degree n greater than 1 has at least one 0, where 0 may be a complex number. And corollary to that, that's really important. Corollary is a consequence to a theorem. So it's like a minor theorem that could be inferred from the bigger theorems, right? It means that every polynomial function of degree n greater than or equal to 1 has exactly n zeros, including multiplicities. So basically what this is saying is what we mentioned earlier, right? For example, if p of x is a n x to the n plus a s m n minus 1 x to the n minus 1 dot 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 all the way to ax plus a to the 0. It means that because the highest power is n, so the degree of the polynomial is n, this implies that there are n complex roots. Okay? Alright guys, so let's do example 3, shall we? The first thing we do is we need to simplify the left hand side as much as possible. If it was just simple factoring question like this, we will do GCF, right? So okay, so that will give you 2 times x to the third minus 6x squared minus 17x plus 201. But if you think about the zero property, it means that either 2 is equal to 0 or this expression is equal to 0. When was the last time that 2 was equal to 0? Answer should be never. So we just cross it off. Or another way to look at it is that we divide both sides by 2. And when we do that, that's what we get. Okay? Now let's take a look at this, guys. This is it has 4 terms, right? In this class, and in most high school classes, when you have 4 terms like that, more than likely, it is a group factoring. So generally, we tend to do the first 2 and the last 2. Okay? Sometimes, however, we may have to do mess it around a little bit, but usually the first 2 and the last 2 is good. If it isn't, try the first and the last and the middle 2. Or first and third, and then second and fourth. But 99% of the time, I'm just making that number up, the first 2 and the last 2 should work. Okay. What do these 2 have in common? Well, they have x squared in common, right? Then when you factor that out, we have x squared, x minus 6. Let's double check if it works. X squared times x gives you x to the third. X squared minus 6 gives you negative 6x squared. Beautiful. So in the next one, we should get x minus 6, right? So we could have a factoring the factoring again, right? If it doesn't, then there's no point to group factoring. Okay, so what number multiplies to negative 17x? Oh yeah, you just factor out negative 17, right? So negative 17 times x gives you negative 17x. Negative 17 times negative 6 gives you 201. Beautiful. Got it. So we factor out these 2, right? Because they're common. And you end up with x minus 6, right? And then what is left? The ones in the red, which is x squared minus 17. Now, when you have 2 things to multiply to 0, one or more of them has to be equal to 0. So x squared minus 17 is equal to 0, or x minus 6 is equal to 0. When you solve that, that is 6. For this one, yeah, we can't really factor that, can we? So we move that to the other side. Well, not in the traditional sense, right? When you square root both sides, be sure to put plus or minus the square root of 17. So we got 1, 2, 3, 3 guys. We have 3 roots. And what's my leading coefficient? Sorry, the degree of the polynomial is 3. It matches them, right? Good. I think we've known it for a while, but we have, for the first time, explicitly stated the fundamental theorem of algebra. Okay? So we state that my x answer is negative root 17, positive root 17, comma 6. Okay? We have 3 roots, and the degree is 3. Once again, the example 4, I like to keep that for the class. So if you'd like to examine it, great. This one requires a little bit of trick. It's not too bad, but I like to share that with you during class. Okay. Before we could talk about writing polynomial function from its zeros, we need to talk about this first. Irrational root pairs, like a plus b root c and a minus b root c, are called irrational conjugates. And complex root pairs, a plus bi and a minus bi, called, that's right, complex conjugates. So basically, if you change the sign in the middle, it's called complex conjugates or irrational conjugates. So there's a theorem in the irrational root theorem. If a polynomial has a root that is a plus b root c, then what the rule says is that a minus b root c is also a root. In complex conjugate root theorem, it says that if a plus bi is an imaginary root to a polynomial, then its complex conjugate, a minus bi, is also a root. Okay. Now, before I begin example 5, we need to notice something about this pair. Okay. Okay, let's put that on the side here. Okay. When you have, let's try something a little bit simpler than this. 5 minus root 2 times 5 plus root 2, let's say, right? What does that look like? Doesn't that remind you of a plus b times a minus b? And that's basically a squared minus b squared, right? It's a factoring scheme. And you could do the same thing over here. So what that means is that that will be equal to 5 squared minus root 2 squared, which is 25 minus 4, which is 21. And let's try the same thing with complex roots, complex conjugate roots, right? 3 minus 2i times 3 plus 2i. It has the same exact form, doesn't it? So what you have here is 3 squared minus 2i squared. So that gives you 9, and minus, that's 4 times the I squared. But I squared is negative, right? So negative and negative is positive. So that will give you 13. So this right here will come in very, very handy for you guys. Okay, let's do example 5. Write the polynomial function with least degree and a leading coefficient of 1 that has the given zeros. So that would mean that p of x is equal to 1, leading coefficient 1, right? Times x plus 5 times, because this is a root, it will be x minus the root, right? 3 plus 2 root 7. And, oh yeah, that's right. Because according to the irrational root theorem, if that is a root, then so must be 3 minus 2 root 7, right? So if that's a root, we could express that as a factor of x minus a root, which is 3 minus 2 root 7, like this. Okay? All right, I think the biggest obstacle right now is to multiply all that out, but you gotta be kind of wise about it. Okay, you can't just multiply these two. The best idea is to multiply the two factors that contain the conjugate pair. Okay? All right, let's do that, shall we? When we multiply these two out, x times x is, we're gonna fold it out, guys, right? Is x squared. And when I multiply this out, it's actually the sum of these two. I don't know if you remember that. Yeah. So it is minus this plus this of x. And the last term is the L. We're going to multiply these two out, which is negative times negative is positive. And if I multiply these two out, okay, let me write that out first, okay? Let's go step. Oopsie. Like this. All right. When you examine this, these two cancels, so I'm not worried. See this two right here, guys? Doesn't that look just like this, where the middle term is changed? So when you have conjugate pairs, whether it be irrational or complex, falls under this relationship when you multiply them. So that means I'm going to have 3 squared minus 2 root 7 squared for this term right there. Let me underline that so you can see it right away. This one and this one, that leads to this. And this right here is, that cancels, so this 3 plus 3, that's negative, so it is x squared minus 6x. And this right here is simply x plus 5. Okay, what does that equal to? That comes out to, can we do that on the side, if you don't mind? So this right here, I'll just put that right there, will be 9 minus 2 squared is 4, and then that's square of the root 7 is 7. So that's 9 minus 28, right? And that'll give you negative 19. So that's negative 19 right there, guys. So I don't want to write it out again, so I'll just leave it alone like that. So basically what we have to do is x times all that. So x times x squared minus 6x, and that's negative 19. And that is equal to, ooh, there's a mistake here I just discovered. Ooh, that should be minus, because that's a root, isn't it? It should be minus, minus, right? It's always x minus a root. So that is a minus, okay? Sorry about that, guys. So it is all that times minus 5. So it's minus 5 times x squared minus 6x minus 19. So we need to distribute this out, okay? You should probably pause the video and try to work that out as a practice to see if you get it correct. And I'll just do it very silently, okay? Okay, there you go. All right, guys, have a good night, and I'll see you in the morning.